Hello and welcome to Science Club Daily. I'm Ross Bolch and today I'm joined by Tina. Hello.
Hello once again.
So today I have a pretty interesting story. Both of us are really into music.
That's
and
for sure.
Sort of a little bit musical.
Just a little bit.
Like to dabble.
Yeah.
And so for me, I'm actually really interested in how the brain interprets music because it's one of those weird things that for humans, we're not exactly sure why we evolved such an affinity for it.
That's true.
A lot of animals use it as like mating calls and things, birds, etc. Even like crickets, you know.
And that's communication as well, if you think about it. Yeah.
But for humans, it really seems to this be kind of a storytelling avenue. And so I've always wondered like how that evolved and what that means.
Sure.
And the interesting thing is, you'd think that music and speech are really quite similar, and obviously they're kind of fundamentally linked in a lot of ways, with early music being made by human voices, compared to, say, instruments that came along later. But it turns out that the two things actually couldn't be further away from each other in the brain.
Okay.
And we've known for a little while that these kind of things are actually decoded in different hemispheres of the brain. So the brain is like two little pieces, and different things happen in different areas of the brain. And so some people in Montreal essentially wanted to find out how this works, and they had a really interesting approach. So what they did is they got a local singer to come in and make 100 different a cappella recordings.
A cappella?
Yeah, so of course for people who don't know, a cappella means voice only.
Right.
And I think the reason for that is so that they didn't confound any variables between spoken words and sung words, because I guess if there were other instruments in the mix, that could kind of mess up the processing.
Yep.
And so, but 100 is quite a lot. And then what they did is they distorted the recordings either temporally or spectrally. So those words might not mean anything to anybody. They certainly didn't to me initially until I kind of thought about it. So temporal dynamics is kind of, as it sounds, like tempo.
Yep.
So
timing, right?
Timing. So words, a lot of human words are actually picked up in the brain with the timings of it. You know, if I say onomatopoeia, those individual syllables don't necessarily make much sense, but that rhythm resonates with us. That's kind of why you can teach dogs basic phrases. They can't understand words, but if you say things in a specific rhythm to them, they start to associate that rhythm as a kind of language in and of itself. Whereas spectral things are more like pitch, and the sort of the shift of the sound.
So you mean like intonation and just the tone of your voice when speaking? Is that right?
So I like there's this weird like Bill Bailey scene where he likes to imagine news themes if they had words. And there's one where he's like, and now this puppy will lick your face.
Oh no.
So the temporal part is, and now this puppy will lick your face. Whereas the spectral part is the ha 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 ha.
So when you merge that together, that's what you're,
and that's what you get. And the cool thing is, because this was in Montreal, this is French Canada, and they did the experiment in French and English, and this was to make sure that the results weren't necessarily language dependent. So obviously in that part of the world, you would have some people who understand basically only English and basically only French, and obviously people who understand both. And so they had 49 participants in this experiment, which is really cool. And we'll actually put a link to a video of the researchers talking about it as well. They got really excited about this research.
Well, I am getting excited about this because this sounds pretty amazing, actually.
So you can imagine they basically played back these a cappella things where either the language part was really hard to understand or the music part had become distorted. And what they found is that if the spectral information was distorted, they actually couldn't pick out the melody. Which makes sense. But the speech was fine, and then obviously it worked the other way around. And what they found is, which is really interesting, is that the speech part of the processing, that actually occurred in the left part of the auditory cortex, on the left side of the brain, whereas the melodic part actually happened on the complete opposite side of the brain on the right. Which for me is crazy, because I would have thought these things would be quite linked. You know, hearing sounds and processing them, you think they'd happen in the same part of the brain. But what this shows us is that an entirely different part of the brain has evolved just to process music, essentially. Which means that music is obviously really important to a lot of life forms. And it's possible that this is actually a holdover from when other species did need music a lot more, perhaps in the past. And the next thing they did is sort of they degraded different parts to see how it affects brain activity. And this is again where they found, if you know what an fMRI is, it's basically functional MRI. And it's where they can see really specific energy and blood flow usage in parts of the brain. And they found the same thing, that if they degraded certain parts, the spectral parts would end up being on the right and the language parts on the left.
So there's some sort of compensation mechanism is what you're saying. If in the event where your primary processing center is compromised, there is a capacity for the other side of the brain to pick up the slack, essentially.
Well, I think...
Is that not right?
I think no, that's the problem, is that there isn't. Like, I think, like, let's say you had an injury to the wrong part of your brain, you could actually end up not being able to experience one or the other. So let's say you got an injury to the left side of the brain, you wouldn't be able to access speech, but you could still completely appreciate music. Whereas obviously the other way around, you might not be able to appreciate music, but language would still be fine. Of course, the brain has some plasticity, but that's kind of one of the interesting things that this research suggests. So I find it interesting that they just sort of really wanted to look at this, and they have really good evidence now about exactly what features of the language and the music and the sounds that we experience and where they come from. And it could be interesting to take this further, looking at other parts of music or speech or, maybe language and stuff. So
I'm actually curious about the language bit, because remember how when each language is spoken, they're spoken with their own types of intonation and their own melody to it as well.
Exactly.
So I'm just curious to see if something is spoken, like a poem, for example, is spoken in a different language because of its own intonation. How is that processed and accepted? And if that's distorted, is that really different?
I wonder if that's, that part of the brain, like maybe the right part of the brain actually detects accents and things like that. Whereas the left side processes as the actual words. Because we live in Australia. And Australians really love to end their sentence as if it's a question.
That's true, I guess.
They do that all the time.
Is that so? I haven't noticed, but
really Australian, really, which is fine. You get used to it, but maybe again that there are certain parts of the brain that maybe are responsible to that, which I find fascinating.
It is indeed.